Okay, let's keep the computational party going. Geometry to the point and beyond. Ghpython node at WICKERSON Studios. Turn this to disable. It's not much of a screensaver, but you know, what are you going to do? Let's jump in here and start from scratch. Go to our math tab, grab our Python node, and see what we can do. This one, we actually are going to erase everything, and of course, start inputting from scratch. We're going to be taking a look at a random, I guess I should do this first, to the point and beyond random point 2D. That's what we're going to take a look at. So we have our script open, and of course you must import some modules, import and libraries. So we're going to import Rhino script syntax. We're also going to import the random, which we recently took a look at. We are going to create a list of points. So we'll do that by what I consider, after studying C# a little bit, that this is literally just a boxed array, and it's empty, an empty array. And we're going to iterate I in range n. And so now we brought a variable into the equation. We need to change our variables, and it will be an integer because we're dealing in Ghpython, and it deals well with integers as opposed to what you can do in C# and what you have to do through different programming techniques to get integer to work well. F-range works within the Rhino script syntax, and we'll take a look at that in a minute. Well, in a little while. So let's take that over to integer so it's working. And let's stay within with the colon, within that scope of this range function. So I'm starting to use the proper geometry, and let's create a point variable as rs function at add point. And why didn't it come up? Because I did not import. So you should know what's going wrong when things don't happen. Let's go back and hit Rhino script, and as soon as I hit dot, I should have an indication of the methods and properties and everything I can use. I guess they're called constructors and things like that. Let's do add point, and we certainly should start to see that come up. And there's add point. Put the parentheses. It tells us what we need. We are going to need a point, y or z, and you can leave that as none. There's some nice examples down here. So Rhino script add point 1, 2, 3. Couldn't be more basic than that. But let's use let's import random as r to save us having to type random every time. R dot. Nice little shortcut. Uniform is what we were getting a decimal at, set between a range of what we wanted. So uniform, and we'll set that between 0 and let's say x. So we're at least having some excitement to our life. And let's do it again in the y direction because we're creating a point. Uniform, autocomplete, and let's do that 0 to y. And let's end with 0 or make it jazzy snazzy at x times y. May as well start customizing everything we're doing. I don't need a capital Y. There we go. And we're going to append those point lists, which were empty, or let's append that with those points that we're creating. And now we'll need an output. Let's go back out of the scope of the function and put points, which is common practice, out equal to points. And if I hit, well, I'm not going to hit run yet because I definitely need an x and a y. This one I actually want to be x just to be consistent. And it will run in an, let's keep it simple as integer so it's not too confusing. And let's take this one over to y. And we'll put that one over to integers. So as soon as you start pushing floats or doubles or decimals, you're going to start running into some things. So let's take the number and set that, what should we call it? Let's see where I could actually bring something in. That's interesting. I'm not using it yet, and I might. But what I'm going to do, I don't have a seed operating in this script that I'm taking a look at, so I'm kind of customizing it. Let's take n and give it a variable. Oops, what has happened? I want to pop something up here. 12 will give me from a slider from 0 to 100 in the integer direction. And then x and y will be the limit on where we want to go. And we'll just do we could do it equally, but let's split it up. But we'll leave it at 12 each time as well. So let's take this up and let's bring these ones down. Well, we'll bring it down to 6 and 4. See what happens. It should run, but we need to have our points out. So let's make sure we're outputting correctly. Points underscore out. And what I always said was make it common practice to go in, make yourself a panel tool for bugs and a panel tool for output. And let's hit run, see if we get lucky. And we did. So we've ended up with a series of points. Let me stretch this out so we see it. We've got, so you can put your param viewer on at this point when you start to have these long lists, so you know exactly what you're dealing with. That'll shorten the information. You've got one branch of 44 points, and there they are. And we should be generating something with n as the range. We could go into here, and I'm just thinking, there's an interesting scripter that's using seed, but yet the seed isn't being applied. Maybe it is, and I'm just missing it. Let's take a look at what we graphically are doing. So close that with the on, and there it is. There's our cluster, and n is a seed. We're taking that, I'm not sure what popped in there, a vector I clicked accidentally. I'm taking that in the y and z direction, and because I did an exponential, it kind of blew up. I think that's probably a bad idea. Let's stay on a simple grid and without complicating it by not an exponential, but a multiplication factor. Let's just take that, and that will run us on the base plane, and then we can really take a look at what we've done. We basically made a cluster of points in a 2D array that's random. And as we run that through n, we're going to end up having all these different seeded, basically the number of points. We get all the way down to 3. And I guess it would be nice to add a seed on here. Let's just add one up here and call this seed. Why not? Seed. And take that seed over to an integer value and put that at whatever, 12. So we have lots of seeds we can put in. But we've got to work a seed into our function. So where can we add a seed? I don't know. Can't we just go into here and make random dot seed and add whatever we want as self, so seed, and it will look for that. I think that will work, and hit test, and random is not defined because we brought it in as R. So let's try that, random seed, there we go. And just a little playfulness, let's hit OK, and see that now we seeded this, and we don't have to change the number to change the pattern. So that was a nice way of bringing in a little seed tool on top of that. That's about it. Can't be more complex or simple than that. And now we have some geometry so we can play with. We take those points out of there. And what would you do with those points? Well, I would take the points, keep my count low to start if I was starting to think about things. I might throw a solid on. I mean, now it's just play, but having control. Throw these on, and let's put a radius in, a range of radius. And our range count, we're actually going to have, the range is going to have a domain of what's working well, a radius of 1. So let's take out a range of 0 to, actually, let's put 0.1 to 2.0. 0. That's going to be the range that we're going to feed into a math construct domain, and that will feed in here as a start and here as an end. So that could be kind of fun, and our domain doesn't go to 0. We'll feed that into our domain. We'll take our amount of points. We'll take a list count to that, list length count to that. And because we have 7 here, and this is outputting, if I plug that in, you're going to find that the range comes out as 8. I'm going to want to step this down in the expression tool as x minus 1 so the data matches. And if I throw that into the radius, I can now have these spheres. And of course, I could throw a random on those as well, but that's pretty interesting. Let's take, let's just run this through as, and actually I think I want this to go even larger. I would like to edit my range up to 4, maybe 5, and see if that changes the radii. And we get this kind of Boolean union madness that's happening here. Let's throw that on so I can roll it around and see what's happening. Now there's spheres in spheres, which are kind of tricky, but we can control that, what's happening within those as soon as we start to get these Booleans touching one another like that. It's just a nice way to make some strange geometries. Think about that as a baked object. And once again, this would be a little tricky to, we don't have to have it on the default. Let's put it together and pull my face out of there. And there we go. We have a little Boolean union on a strange object that if we take a look at now, let's pop it off Grasshopper. There we go. We made this strange object that's made from a whole series of things that we do a Boolean union. Hopefully it'll work if there's a single object just sitting in the middle. Boolean union. There we go. We've made a pretty cool object in Rhino through computational control, through parametric control in the nodal scripts in Grasshopper, but through computational programming within the Python node. And there you go. You made something that's you can have as many iterations as you want. Now, I'm not sure why you want to make this and why you'd want to end up playing with it, but it's another way to come about building geometries, and that's why I'm playing with it. Simple little applications of customized nodes that do a little more than maybe if we went into sets, sequences, and grabbed the random tool and said, okay, what does this one do different from that one? So we've called it TTP random point 2D. Let's copy that. Let's make another test. Let's make another test user object. We'll just pop that into here. We will go to our icons. We'll grab it, put it in the red. It's kind of cautionary. Go over to WICKERSON Studios, hit go. And I think we've popped on, 3 of these little test nodes. So you've got the one that it kind of was inspired by, the sense of random. You've made this customized GIF node, and then you've got this random 2-point that you can actually make your own. So with a little shift, control shift, pull that down into here, pull this one up into here, and then delete that one. You don't even need to look at it anymore. You've got your customized node that you can go in and explore. Know that you made it, know that you scripted it, and know that you can go in and computationally change whatever you want to do to it. And that's what I'm basically doing. I'm running through this series. I'm studying from this Chinese text. I'm applying the scripts within it from the GH computer-aided geometric design. And we will go into a 3-point array, and then you're going to find out exactly what we did up here, because this is basically the 3-point array example that I've been using. Put this one on preview, and what would you do if you gained control of all of these geometries? And here they are. As we zoom back out and leave Grasshopper, I think like that, you get nice colors being applied to. And that's the next example, the one that we've kind of been inspired by. And then we'll get into geometries like lines, vectors. They're moving those things by those vectors, attracting points by those vectors. And we'll get into curve attractors and bricks past the vectors. Thanks very much for watching. 12 minutes.